Hello everyone, welcome to Zen Go. I'm Vincent. Today we're going to talk about a topic that might completely flip your understanding of how the AI era began. Many people think the AI era started with ChatGPT, released by OpenAI in 2022. But actually, the true origin of this intelligence revolution goes back to 2016. That spring, in a game room in Seoul, South Korea, a program called AlphaGo completely changed humanity's understanding of machine intelligence. This is why my video intro animation shows a monk playing Go, because it all relates to this ancient game that's considered the pinnacle of human intellectual sports. Let's go back to that historically significant moment. In March 2016, the whole world's attention was focused on a human-machine battle in Seoul, South Korea. On one side was Lee Sedol, a Korean 9-dan Go master, and on the other was AlphaGo, an AI program developed by Google DeepMind. Well, you could think of it as the embryonic structure of AI, like a sperm, if you will. This wasn't just a Go match. It was more like the ultimate showdown between human wisdom and machine intelligence. The complexity of Go far exceeds our imagination. A Go board has 361 possible move positions, and when you multiply each step's choices, 361 times 360 times 359 times 358. Under this compound effect, the number of possible game states is greater than the total number of atoms in the universe. This means that even the most powerful computers couldn't use brute force search to exhaust all possibilities. More importantly, Go masters usually rely on intuition and experience, not pure calculation. That's why, before AlphaGo, almost all experts believed that AI defeating humans in Go was basically impossible. With current computing power, the required resources and computing power would be comparable to landing on the moon. But DeepMind's research team obviously didn't think so. They designed a revolutionary architecture for AlphaGo: deep neural networks plus Monte Carlo tree search. Simply put, they gave the machine both human-like intuition and computational abilities that surpass humans. The policy network learned from millions of expert human games, learning to identify the most promising moves in given situations. The value network was responsible for evaluating the overall board position, quickly judging win probability. And Monte Carlo tree search, guided by these two networks, conducted deep reasoning and calculation. Before officially challenging Lee Sedol, AlphaGo had already achieved a 5-0 victory against European Go champion Fan Hui. But the outside world generally thought this wasn't a big deal because Fan Hui's level still had a gap compared to world-class masters. The real test was Lee Sedol, this Korean national treasure of a player, famous for his bold and innovative playing style, who had been studying Go since age 8 and had barely taken a day off. Before the match began, almost everyone thought Lee Sedol would win easily. He had once been the number one figure in the Go world, standing at the pinnacle of Go wisdom exploration. Lee Sedol himself predicted he would defeat the AI 5-0 or 4-1. But the progression of the first game shocked everyone. AlphaGo took a very long time to think on its first move, and the media was still mocking its slowness. But the commentators quickly realized that this game was intense from the very beginning. AlphaGo played with extreme precision and strong aggression. What was even more shocking was that, no matter how complex the position became, AlphaGo could complete its thinking within 1 to 1.5 minutes, as if it had foreseen everything. This calmness made Lee Sedol nervous, and he instinctively tried to get information from his opponent's expression, but facing him was only Dr. Huang Shiji's emotionless face as he placed the stones. Machines have no expressions and no emotional fluctuations. Game 1, Lee Sedol lost. Facing the media's flashing cameras, he admitted he had underestimated his opponent and now thought the win probability was 50-50. But Game 2 was even more stunning. AlphaGo made a move that left all Go experts scratching their heads. A shoulder hit on the 5th line. By conventional understanding, this position was too high. It was practically selling territory. To put it in terms outsiders can understand, it was like suddenly stopping to taunt your opponent during a top-lane duel in League of Legends, or switching to a sniper rifle during close combat in Counter-Strike. The program showed this move had only a 0.01% probability, but an extremely high win rate. This was AlphaGo's original move, surpassing thousands of years of human Go knowledge. A few hours later, a miracle happened. That seemingly useless move created a chain reaction. All the stones on the board were connected by it, forming a complex network that influenced the entire game. At that moment, all the Go masters watching realized they were witnessing a completely new era in Go history. After losing 3 games in a row, Lee Sedol's pressure reached its peak. If he lost the 3rd game, it would mean humanity had completely lost to machines in this field considered the pinnacle of intellectual sports. But the pressure made him change his style, and when you start changing yourself to adapt to your opponent, you've already lost. Game 3. AlphaGo won again. After the match, Lee Sedol fell into deep self-doubt. He even apologized to all humanity for his incompetence. But the story wasn't over. Game 4 was actually Lee Sedol's shining moment. When the outcome was decided and the pressure disappeared, he found himself again. On move 78, Lee Sedol played what was called the Hand of God, a dig that successfully touched AlphaGo's computational blind spot, causing this seemingly flawless program to malfunction. This move had only a 0.007% probability. In AlphaGo's calculations, just like its previous miraculous 0.01% move, both were 1 in 10,000 innovations. Lee Sedol won back a game, proving that human creativity still had its unique value. Or rather, to beat AI, you really need to think like a hacker about its model vulnerabilities, instead of stupidly relying on your own strength. Or just physically unplug the network and power cables. That winning method should be the most effective. But AlphaGo, good at learning, wouldn't give Lee Sedol a second chance. In Game 5, it won narrowly by 2.5 points, ultimately winning the entire series 4-1. In AlphaGo's logic, winning is winning. Winning by half a point is still winning. This was an important lesson it taught humanity. The impact of this match went far beyond a Go game. It was like the Sputnik Moment of the AI field, completely igniting global enthusiasm for artificial intelligence research and investment. AlphaGo's success proved several key points. First, deep reinforcement learning has enormous potential. Machines can not only learn rules, but also reach levels surpassing humans through self-play. Second, AI demonstrated a kind of computational creativity, not just brute force computing, capable of discovering knowledge domains humans had never touched. Most importantly, it opened the door for AI to solve scientific problems. The DeepMind team generalized AlphaGo's core ideas to create the more general AlphaZero, then AlphaFold to solve protein folding problems. This proved that AI technology developed for games was fully capable of solving the most complex scientific challenges in the real world. But AlphaGo was just the beginning. Its victory inspired the entire AI field, making researchers think, if machines can show intelligence, surpassing humans in complex games like Go, what about other fields? Language understanding, image recognition, scientific discovery. Would all these bastions of human intelligence be conquered one by one? The answer to this question appeared in 2017. That year, Google published a seemingly ordinary paper, Attention is All You Need. This paper proposed the transformer architecture, laying the foundation for the later language AI revolution. If AlphaGo was AI's victory in the gaming domain, then Transformer was AI's breakthrough in the ultimate challenge of understanding human language. The complexity of language actually far exceeds Go. While Go has infinite variations, its rules are fixed and its goals are clear. But language? The same sentence can have completely different meanings in different contexts, full of metaphors, irony, cultural background, and even the speaker's emotional coloring. To make machines truly understand human language is almost like teaching a chimpanzee to understand all the cultural nuances on Earth. Inspired by AlphaGo's success, OpenAI researchers began a crazy experiment. Let AI read the entire internet. Their idea was simple yet bold. Since AlphaGo could master Go through massive game records, why not let language AI learn the same way? So an AI system began reading Wikipedia, news websites, forum discussions, books, papers, and even fragmented social media content, day and night. This process took years and consumed millions of dollars in computational resources. But just like AlphaGo discovered new Go strategies, through self-play, this language AI gradually mastered the subtleties of human language through massive reading. It learned when to be formal, when to be humorous, what kind of response would satisfy the other party. On November 30, 2022, when ChatGPT first opened to the public, the first user's reaction could be described as shocking. This wasn't polite technical praise, but a deep shock. This thing really understands what I'm saying, just like the feeling people had when they saw AlphaGo make that miraculous 0.01% move. ChatGPT's explosive success was actually a continuation of the AI revolution that AlphaGo began. From the Go victory in 2016 to the language breakthrough in 2022, these 6 years witnessed AI's magnificent transformation from game expert to general assistant. AlphaGo proved that machines could surpass humans in the most complex decision-making problems, while ChatGPT proved that machines could also reach practical levels in language understanding, a core domain of human intelligence. More importantly, these two milestones adopted similar core concepts, letting machines discover knowledge domains humans had never touched through massive self-learning and reinforcement. AlphaGo discovered new Go strategies through self-play, while ChatGPT mastered language subtleties through massive reading. This brute force aesthetics approach, while resource-intensive, was surprisingly effective. Now, when we look back at this AI development history, we can clearly see a trajectory. From AlphaGo's game intelligence, to AlphaFold's scientific applications, to ChatGPT's language revolution, each step was a deepening and expansion of the previous one. AlphaGo didn't just win a Go match. It was more like lighting the spark of the entire AI era. Today, we've already seen AI's widespread application in various fields: medical diagnosis, autonomous driving, scientific research, creative design. Almost all fields requiring intelligence have begun to see AI's presence. And all of this can be traced back to that spring in 2016, in a game room in Seoul, South Korea, where AlphaGo made those moves that shocked human masters. Looking to the future, we might see even more powerful AI systems emerge. Multimodal AI, embodied AI, artificial general intelligence. These concepts are no longer science fiction fantasies, but technical goals gradually becoming reality. But no matter how technology develops, the insights AlphaGo left us remain important. AI isn't meant to replace humans, but to form new collaborative relationships with humans. Just like Lee Sedol, who, after losing to AlphaGo, actually went on to win consecutive matches afterward. The true value of human-machine competition isn't about determining winners and losers, but about mutual inspiration and joint progress. In the AI era, the most important thing isn't fear or resistance, but learning to cooperate with these powerful tools and leveraging each side's advantages. AlphaGo's story tells us that technological breakthroughs often come faster than we imagine, and their impact is more far-reaching. When we were still debating whether AI could defeat humans in Go, it was already thinking about how to solve protein folding problems. When we were still amazed by AlphaGo's Go level, ChatGPT was already helping hundreds of millions of people solve daily problems. So what will be the next domain conquered by AI? Where will the next shocking hand of God appear? Perhaps the answer lies in the not-too-distant future, waiting for us to discover. Alright, that's it for today's sharing about the origins of the AI era. If you found this story interesting, don't forget to like and subscribe, and feel free to share your thoughts on AI's future development in the comments. Remember, we're witnessing history and creating history. See you next time.